Hi, welcome to the wonderful world of trigonometry. So today we're going to start with a problem. It says an angle in quadrant 2 has a cosine of -6/7. What's the sine? Now it says sine, and that little zero with the line through it is the Greek letter theta, and that's the variable we use to show an angle. So what's the sine of theta? We know the cosine is -6/7. What's the sine? And there's got to be a connection to all this. So let's kind of look at what we've done before and see if we can find a connection. If you remember the old unit circle, we would put our little triangle over here. And remember we used the special triangles, the 30-60-90 triangle and the 45-45-90 triangle. And we realized that the x-coordinate was the cosine, and then the y-coordinate was the sine. So for 30 degrees, we know the cosine is radical 3/2, and we know the sine is 1/2. Well, we don't have either one of those values, but if you remember, we used the Pythagorean theorem to figure those values out. And remember, on the unit circle, we have that convenience that the radius is always 1. The radius is always 1. Now here, the radius is going to be the hypotenuse of the right triangle. So what we can do is make a right triangle out of it. So let's see. Two things that we know. Let's see. We know that the cosine of the angle is -6/7. And we know it's in quadrant 2. Okay, we need to find the sine of theta. Now, if you look in quadrant 2, or quadrant 1, quadrant 2, now the sine is always going to be the y-coordinate, and the y-coordinate here is always positive. Okay, so we know our answer is going to be a positive number. Okay, so we're looking for a positive number. Now, remember we used Pythagorean theorem to find everything on all the coordinates of the unit circle. And Pythagorean theorem was a squared plus b squared equals c squared. Well, the nice thing about all this is our hypotenuse c is going to be 1. We can go ahead and square 1. Now, the a squared and the b squared, we're going to remember all this. The a is going to be like the length. We can call that this leg, and the b would be this leg. So we remember that this leg, the x-coordinate, was already defined as the cosine. So instead of saying a squared, we can say cosine squared. And then the height, instead of calling that b squared, we can just, we know that's going to be the y-coordinate here on the unit circle, and that y-coordinate was previously defined as the sine. So we can say sine squared theta plus cosine squared theta equals 1. Now, there's a little thing here. Notice it says sine, and then I'm putting the exponent, and then I'm putting the angle. Okay, we're squaring the sine, we're not squaring the angle. So that's just how that is written. That's a little bit different than what you've seen before. So we knew the hypotenuse was 1. So now the other thing we knew is we know what the cosine is. So we still haven't figured out the sine squared theta, but we know the cosine is that -6/7. Now we have to square that, and then 1 squared is just 1. 1 times 1 is 1. Now from here we can say, let's simplify things up a little bit. -6/7 squared is going to end up being a positive 36/49, and that still equals 1. So, whoops, this is sine squared theta, by the way. Now, I need to get sine squared theta by itself, and then I can take the square root of both sides. So one way to get rid of that 36 over 49, let's go ahead and subtract 36 49ths. And what you do to one side, you do to the other. And let's rewrite where we're going. So we have sine squared theta equals, and then if you just do that in the calculator, 1 minus 36 over 49, that's going to be 13 49ths. Now, I don't want sine squared theta. I want sine of theta. So I'm going to take the square root. And what you do to one side, you do to the other. So sine squared theta, so that's going to be sine of theta. Got rid of that square. Now remember, when we take the square root, it could be a plus or a minus. Now we're just going to keep this radical 13 over 49. Now one nice thing we can do right here is we can say this is plus or minus. We can put radical 13 upstairs and radical 49 downstairs. Well, heck, what's the square root of 49? Well, the square root of 49 is 7. Can't really do anything with radical 13. Now, we figured out so far that the sine, it's either plus radical 13 over 7 or minus radical 13 over 7. But remember, we said it's in quadrant 2, and we said all the y coordinates in quadrant 2 are positive, and then the signs are the y coordinates. So we know we need a positive number. So we know for a fact that the sine of theta equals radical 13 over 7. I'm just going to leave the positive there. I'm not even going to worry about the negative one. I know for a fact it's positive. So you're sitting there saying this couldn't possibly be true. How could we figure out, or how can we check our answer? So let's go over here. Now, we knew that the cosine of theta was negative 6 over 7. We just figured out that the sine of theta was radical 13 over 7. And we said a minute ago that this is called the Pythagorean trig identity. I didn't call it that before. That's the name of it if you're big into names. Sine squared theta plus cosine squared theta equals 1. And we can make that look a few different ways, but that's what it is. Now, I'm going to replace sine with radical 13 over 7, and I'm going to square it. Now the cosine, we already knew that was negative 6 over 7. I'm going to square that, and all that should equal 1. Let's get out the handy dandy little calculator and just double check this. So I'm going to put radical 13 over 7, and then I'm going to square that, and then I'm going to add another fraction, negative 6 over 7, square that, and it equals 1. I hope you can see that. I'm sorry, my little computer calculator is not working right now, but that's what it is. So now the worksheet you're going to get is going to look like this. Notice we start out by telling you what quadrant it is. Now in quadrant 1, I've given you cosine. Quadrant 1, both x and y are going to be positive, so you know your answer is going to be positive right off the bat. Now in quadrant 2, we just did one in quadrant 2. We know that the cosine is going to be negative and the sine is going to be positive. Okay, that's not. Now all of a sudden, number 3, we did that math teacher thing where we changed something. So did I tell you what quadrant this is in? No. You have to get out your unit circle. This is between pi and and 3 pi over 2. So you know radians. Pi radians is going to be at 180 degrees. So and then it's going to go to 3 pi over what was it? 3 pi over 2. And that's going to, so that was between 180 and 270 degrees. I didn't tell you that trick yet. We'll yet to teach you. But that's in the third quadrant. So you know that the x is positive, the x is negative, and the y is negative. So whatever answer you get for number 3, you're going to put a negative sign in front of it. Now, 3 pi over 2 and 2 pi, that's where this at. Instead of telling you which quadrant it was in, they're telling you that. And if you get stuck, you can just convert the 2 pi into degrees. But hopefully you already remember that that's 360 degrees. So that's quadrant 4. So that's right down here. So the cosine is going to be positive and the sine is going to be negative. So I'll let you do the rest of them. Good luck, and wish us luck in Houston. Hopefully we're going to win one.